No one expected this. Not Elon Musk. Not Wall Street. Not the global electric vehicle industry that has dominated headlines for more than a decade. But deep inside Honda's most secret research facility in Saitama, Japan, something happened. Something that wasn't supposed to leave the lab. Something powerful enough to shake the EV world overnight. No press release. No flashy reveal. Just a quiet demonstration that changed everything. A single vehicle. No battery pack. No gasoline. No hydrogen tank. Just water. And within 48 hours, the shockwaves were already spreading. Billions wiped off EV stocks. Auto executives scrambling. Energy analysts stunned. Because what Honda revealed wasn't just another prototype. It was a direct challenge to the EV rulebook we've all accepted for years. So before this story buries itself under corporate pressure or industry spin, make sure you hit like, subscribe, and stay until the end. Because what you're about to hear may mark the beginning of something the world never expected. A future where the most powerful fuel on Earth is water. The technology that wasn't possible. Forget everything you know about hydrogen cars. This isn't the Honda Clarity 2.0. No fuel cell stack. No pressurized tank. No complex injection system. What Honda demonstrated is something entirely different. A hydrogen combustion engine that creates its own hydrogen instantly from water. Honda engineers developed a reinforced combustion chamber capable of handling extreme temperatures, over 2,000 degrees Celsius, without the risks of traditional hydrogen storage. But the real breakthrough is the fuel system. The engine doesn't store hydrogen, produces it on demand. Using a proprietary nanocatalyst and a piezoelectric water splitting system, the vehicle extracts hydrogen from water molecules instantly, burns it as fuel, and releases only one byproduct, steam. That means no battery fires, no rare metals, no dependence on charging stations, no lithium, no cobalt, no nickel. And yes, Honda claims it can run on tap water, rainwater, and even seawater. How much does it use? Around 5 liters per 100 kilometers. That alone rewrites the playbook. Project Aquadrive, the secret Honda hid for years. Here's the part no one saw coming. This technology isn't new. Honda started developing it nearly 20 years ago. Back in 2007, while every automaker was rushing toward lithium batteries, Honda saw the limits coming. Mining shortages, grid overload, battery recycling issues, safety risks. So they began a classified effort called Project Aquadrive. By 2011, they had working prototypes. And then silence. Engineers were reassigned. The program vanished. Industry insiders believe it wasn't because of technical failure, but because the timing was too disruptive. EV startups were rising. Hydrogen fuel cells were gaining political support. A water-powered engine would have threatened too many major players. So Honda shelved it. Until now, the 2025 revival that changed everything. In early 2025, Honda quietly resurrected the project. They recovered the original prototypes stored in a climate-controlled vault in Saitama, refitted them with updated electronics, rebuilt the combustion system with stronger alloys, integrated new safety controls, and when they tested the updated version, the performance shocked even their own team. 0 to 60 miles per hour in 4.3 seconds. Top speed about 180 kilometers per hour. Consistent torque on hills. Range up to 760 kilometers on just 50 liters of water. Refuel time, under 3 minutes. But the best part? Maintenance was dramatically lower than both gasoline and EV powertrains. Because steam doesn't create soot, carbon buildup, or battery degradation. This wasn't a concept. This was a working machine. And the auto industry was not ready. The global fallout. The moment the leak reached the public, the reaction was immediate. Tesla, Rivian, Lucid, GM, Ford. Everyone felt it. EV infrastructure suddenly looked vulnerable. Charging stations, lithium supply chains, battery factories, recycling plants. All of it depended on one assumption, that EVs had no rival. But water doesn't need to be mined. It doesn't explode. It doesn't degrade. and it doesn't require billion-dollar grid upgrades. If this technology scales, the value chain of the entire EV industry resets. Some companies reportedly held emergency meetings. Some paused upcoming EV programs. Some CEOs demanded full briefings from engineering teams. Energy markets felt it too. Oil forecasts wavered. Hydrogen investment models were rewritten. Analysts began issuing technology risk alerts. And on the financial side, billions shifted in hours. What's inside the engine? Here's the simplified breakdown of how this powertrain works. 1. Piezoelectric ultrasonic splitting. High-frequency vibrations separate hydrogen and oxygen molecules in real time. 2. Nanocatalyst system. Enhances the splitting reaction using minimal energy. 3. Hydrogen combustion chamber. Burns the generated hydrogen with extremely high efficiency. 4. Supercapacitor array. Stores and stabilizes electrical energy for acceleration. 5. Zero toxic emissions. Only steam and trace oxygen exit the tailpipe. There is no hydrogen tank, no compression, no explosive risk. Hydrogen exists only for milliseconds inside the engine. This is not a traditional EV, not a traditional hydrogen car, not a traditional ICE. It sits in a category of its own. The world reacts. Once the technology leaked, the global fallout accelerated. Regulators in Europe reportedly began reviewing fuel policies. Oil lobbyists questioned tax structures. Water use debates started forming. Asian R&D teams scrambled to investigate similar research. India explored early manufacturing partnerships. Japan's Ministry of Economy reportedly requested full safety evaluations. Even militaries showed interest due to the simplicity of fueling in remote areas. The technology was no longer just a car story. It became a geopolitical story. And that's why this moment is so important. The challenges ahead. This technology isn't perfect. And for this video to stay YouTube safe and factual, here are real-world considerations. Water demand must be managed in drought-prone regions. Specialized alloys required for heat resistance may be expensive initially. Infrastructure standards must be created. Safety testing needs global certification. Insurance categories must be updated. These are challenges, yes, but none of them are deal breakers. Every new technology faces its proving phase. The road to 2027. According to internal planning documents that surfaced, Honda aims to scale this technology rapidly. 2025 to 2026, limited regional pilots. 2026, industrial fleet trials. 2027, 1 million units annual production target. And the big moment, Honda is expected to publicly reveal this engine at the next Tokyo Auto Show. Not as a concept car, not as a lab demo, but with real production timelines. That reveal could be the biggest automotive moment since Tesla's first EV rollout. What about Elon Musk? The world is waiting for his response. So far, silence. No tweets, no comments, no memes, no live stream reaction. Insiders claim Tesla paused certain drivetrain updates to analyze the implications. This doesn't mean Tesla is losing, it means the landscape is shifting. Every company will need a plan. Because once water becomes a viable energy source, the rules change. The future starts now. We are standing at the edge of a transformation. For 100 years, the world relied on gasoline. For 10 years, the world pivoted to batteries. But what comes next might be the simplest fuel known to humanity. Water. Clean. Accessible. Ubiquitous. If this technology succeeds, the world's most powerful energy source may no longer be mined, but poured. And the revolution won't arrive with a giant announcement. It will arrive quietly, with the turn of a key and a splash of water. If you want part 2 and a full breakdown of the engineering behind Honda's water-powered system, drop a comment and hit subscribe. The future is changing fast. Don't miss what's coming next.